Hello everybody and welcome back to Business Statistics Online at Frederick Community College. In this video I will talk to you about measures of relative position, and in particular we'll use Excel to construct percentiles, find the interquartile range, and 5-number summary, as well as constructing a box and whisker plot. So we will be using the data that contains information about number of students in calculus courses for the last 2 years, and we're going to answer all of these questions. So the first one is asking us to compute the percentiles. To do that by hand is actually pretty tedious, but thankfully we don't need to do that by hand with Excel. So 30th percentile, we're going to use command percentile.exe. Open the parentheses, and now we need to highlight the data that we would like to work with. Okay, so it's A1 through A40, comma, and 30th percentile, we need to plug in 0.30, and we get this number right here, 25. So 25 students in a course. This number, this size of a class, represents 30th percentile in this data set. Okay, then 80th percentile we can do with the same command, exe, highlight our numbers, then go to 840, 0.80, and now because the percentile is higher, we should also get a higher number, and we get 38. Then the next one will be 95, so let's see, that's percentile.exe, highlight our numbers up to 40.95. We get these numbers. Let's see, what is the decimal? Okay, so these are the decimals right now. Because these are people, you of course would round this up to 39 and 46, but I just wanted to see computation wise, this is what you would have gotten. Okay, so this task is done. We should be able to compute any percentile if we have a set. Okay, now the next one is asking us to find interquartile range and upper lower limits if we wanted to figure it out if we have outliers in this set. So interquartile range relies on Q1 and Q3, and if you know what they are, which they're just 25th, 50th and 75th percentile, then those are easy to find. So we're going to use percentile, get our data. Q1 is the first quartile, so the first quarter, that's 0.25. We get this number here. 50th, that's the median, right? So we can also find it by this command, go to 40.5 or 0.50, that's my 50th percentile, and Q3, it's the third quartile of 75th percent, right? So we'll do this same data set up to 40.75. We're good to go. Okay, so that's our Q1, Q2, and Q3. Now to compute IQR, that is Q3 minus Q1. Okay, so the interquartile range is the difference between Q3 and Q1. Okay, so let me make sure it's all the same format. Okay, so that is our IQR, and this is what we need when we need to come up with the lower and upper limits for the outliers. So what is the lower limit? The lower limit will be Q1 minus 1.5 times the IQR. Okay, what about the upper? The upper is Q3 plus 1.5 times the IQR. Okay, so these are the values that will tell us if we have any outliers, right? So any number that's smaller than 5.125 should be an outlier, and any number that's larger than 54.125, since these are people, we would round them up, then any number that's greater than 55 would be an outlier. Okay, so goal 2 is done. Now it says compute the 5-number summary. How do we do that? What's the 5-number summary? Actually, the 5-number summary would be minimum, maximum, and Q1, Q2, and Q3, which we already know what they are. So here's your 5-number summary. Let me highlight this a little bit. Okay, so now we just need to figure it out what the minimum is. And that one is really easy. So you would just plug in min, open the parentheses, get your data. That's it. So the minimum is 18. 18 is the smallest number. So 18 was the smallest class, and it is not smaller than 5.125, so we don't have an outlier on the lower side. Let's find the maximum. That's the same command as you might think, max. We're gonna go through A1 to A40. The maximum class size was 51, so we don't have outliers on the upper side either. Okay, so 5-number summary is done. There it is. It's just min, max, and the 3 quartiles. So the last thing that we need to do is construct a box plot. Okay, to do that, we're going to highlight all of our numbers and then go to insert, go to recommended charts, and here you see this these type of charts. That's not what we want. We want to go to all charts and pick box and whisker. Okay, and here's your chart. Now the only thing about Excel, it puts the boxes in this vertical position, right? So if you were to do it in a different program, we'll probably do it in horizontal, but it doesn't matter. That just gives us the idea how the data is spread out. So looks like we have a little longer tail on the right. It doesn't look like we have any outliers. But it looks like this data is a little bit right skewed, right? Because this tail right here would be on the right, this one would be on the left. If we have a longer tail on the right, that's right skewed. And of course you can change your title and modify this box plot to your preferences, but this is what you would do to construct a box plot in Excel. So that's done. The only other thing that I would like to show you guys that's not included in the goals, but what if I wanted to compute the rank, the percentile rank of a number? So let's just say, let's see, which one do I want to pick? So let's say 19. Let's highlight this guy. What is the percentile rank for this size of class? So how would I do this? So this is how I'm going to do it. I'm going to say equal percent rank dot exe. Okay, we're going to highlight our set of data, so that's A1 through A40. Then I need to tell my function which number I'm looking to find the rank for. 19. And significance will tell us how many significant figures, so how many decimal places. So let's say 4. Okay, so 0.487, this number means what? That 19 is roughly the 5th percentile. Okay, this is about 5th percentile. So if you need to find the rank, that's the command that you would be using. Percent rank.exe, range of your data, the number that you need to find the rank for, and then the number of decimal places. So it's not asking you to do it in this particular set of problems, but on homework, on online homework, you will have an example like that. Okay? All right, I hope you found this helpful, and Thanks for watching.